Here are 3 gotchas to look out for related to NuGet packages when you're migrating an application from .NET Framework to .NET Core. Hey everybody, it's Derek Martin from CodeOpinion.com. If you're new to my channel, I post topics around software architecture and design in .NET. So if you're interested in those topics, make sure to subscribe. So there are 3 kind of issues that I ran into with NuGet packages when upgrading or migrating from .NET Framework to .NET Core. These could apply to various different libraries that you're using. You'll have to find out. I'm going to show some specific examples using some specific NuGet packages. So the first issue that I ran into is API surface. And what I mean by that is just because you're using the exact same version of a NuGet package does not mean that the actual library itself, its APIs that it provides, are going to be the same. And this is because of a thing called ifdefs. So I'm actually using it here. I have this method called runtime, and I'm saying if I'm running in .NET Core 3.1, then this is the statement that you want to compile. If I'm going to be targeting .NET 4.8 when I build, this is the line that's going to be targeting. So you can see here that I have 2 different statements depending on what I'm running. And if I switch between .NET Framework and .NET Core, depending on what I build, each line's going to run. Libraries can do the exact same thing. So when the output, depending on what you're going to be running on, you may be using the assembly that was built for .NET Core or .NET Standard, or the one that was potentially targeting .NET Framework. And so that means that the libraries themselves, even though it's the same version, may not actually be the same. An illustration of this in a very specific package is in the AWS SDK. So to kind of show this is I will use the AWS's S3 client. So if I do var client equals new Amazon S3 client. Now in .NET Framework, if I'm targeting .NET Framework, which I'll switch here, so I'm using it, this is using a specific assembly that's targeting .NET Framework, and you can do things like get object. So this would actually get an object when you get object request. Now this is all great, works under .NET Framework, but all of a sudden when you switch and you try to build into .NET Core, you'll see what happens here, is that it's telling me that this is internal. And the reason being is if I look at this version, the .NET Standard version, you can see that this is marked internal. If I decompile, if I go back, well actually I can just run it and look at the .NET Framework version, you can see that it's actually public. So there are 2 different assemblies that are in the NuGet package, and depending on which one you're actually targeting against is depending on what APIs you're actually going to see. So that's kind of the first big gotcha, is realize that even though you're using the same version of a NuGet package, its API surface may be different. All right, so the second gotcha, it's just worse than the first, which is it happens at runtime, and you don't really notice there's an issue until runtime, and that is behavior differences. So there's actually behavior differences between the .NET Framework version or the .NET Standard .NET Core version that you're potentially using this. So to illustrate this, I'm going to actually use node-to-time. So this is actually fixed in the latest version of node-to-time in 3.0, but in prior versions there actually are behavior differences, and I'm going to show you what they are. So what I'm going to do is just use the node-to-time API here. So I'm just going to create a zone. This is really unimportant for if you're not using node-to-time, but just to illustrate the issue itself. Let's create a new zone datetime. Datetime UTC now, and then we'll do it in this zone. So the issue here, oops, for a bracket, is if you serialize this zone datetime, it actually serializes differently if you're using .NET Core or .NET Framework. So, and this isn't because of JSON.NET, this is actually because of node-to-time, because node-to-time has an attribute, or it implements an interface, I think. Can't remember specifically in the version that defines how it's going to serialize in the .NET Framework version. So I'll just write this out. So I'm just going to serialize this zone data object and print it out, and we'll see what the output is. Let's go over to the terminal. So let's run this as this is what this is going to look like in .NET Core. Not very easy to look at, but you can see it's this big kind of blob object. Now, if I run it as net48, you'll see this looks very different. It's a much smaller object that gets created in JSON. So if you end up serializing this and then trying to deserialize this in another process, if you're trying to migrate, again, this is kind of a problem. You're only going to really notice this at runtime. So gotcha number 2, runtime differences. All right, so the last gotcha, the third, is just differences in the BCL in terms of naming and where things are. So to illustrate this, I can again serialize and use JSON.NET, the Newtonsoft, to basically show you where BCL is. And the easiest way to do this is with JSON.NET. So I'm going to create some settings. And if you create settings and you do type handling to all, when you serialize, so let's create a new list of strings, and I'm going to put one is Derek, the other one is code opinion, and then we'll serialize this with my type handling. So what this is actually going to do, let's log this. What this is going to do is add a $ type property to the output of the JSON so that when you deserialize it, you get exactly that same type information. So let's run this so you can see what that actually looks like if you've never done this before. So I'll run it under .NET Framework. So you can see here, that list is in system collections generic.list, but this is in MS Core lib, and that's what is under .NET Framework. If I run this under .NET Core, you will see that it's a different output of system.private.core lib. The problem is when you try to deserialize this is going to fail because it's not going to know if you're in between the two, you're going to run into this issue. So again, type information when you're using .NET Core and .NET Framework are different. If you're using JSON.NET and you're using type handling.name.all, and maybe you're storing that in a file somewhere in blob storage or in a database, or maybe you're communicating between different services and you're using type handling all. If you have some services that are running on .NET Core and some services in .NET Framework, you're going to have a problem here, especially when you're using this serialization, which includes the type information. Those are the 3 issues I've discovered with multi-targeted NuGet packages when migrating from .NET Framework to .NET Core. So again, the first is API surface being different. Just because you're using the exact same version does not mean the API surface is going to be the same. Gotcha number 2 is it doesn't mean behavior is going to be the same. And unfortunately, the only way you're going to discover this is through testing and at runtime. Gotcha number 3 is type information. Although the namespaces and type names are the same in the BCL, the actual assembly name is different. So be careful, specifically if you're using JSON.NET. If you've done a migration and you've run into issues with NuGet packages, what was your experience? Let me know in the comments. If you enjoyed this video, give it a thumbs up. And please subscribe for more software architecture related videos.